Before we go into how to create a direct formula, let's remind ourselves how they work. Throw back to lesson 12. If I have a function rule or a relation rule and I want to create a sequence from it, I just insert numbers 1, 2, 3, 4, 5, and 6 in for my variables. So when x is 1, g of x, g of 1 is negative 3 times 1 plus 240, which is 237. And when x is 2, negative 3 times 2 is negative 6 plus 240 is 234. And when x is 3, negative 3 times 3 is 9. Negative 9 plus 240, 231. When x is 4, negative 12 plus 240, negative 228, and so on. I could create a sequence that way. Okay? Hit pause, see if you can create the sequences for the next two, and then unpause and look at what I've got. Second sequence. 13, 15, 17, 19, 21, 23. Okay, that's what you should have gotten. Third sequence, negative 5, 2, 9, 16, 23, 30, and so on, right? 1, 2, 3, 4, 5, 6. 7 times 6 is 42, minus 12 is 30, right? So that is how we generated sequences given a rule. Now, what we want to be able to do is go backwards, okay? This is how that will look. If you remember back to lesson 19, when we were looking at recursive rules, you know that we could look from one term to the next and see a pattern, right? So in this first sequence, the pattern is count down by 3s. Okay, in the second sequence, the pattern is count up by 2s. And in the third sequence, the pattern is count up by 7s. Now, I want you to take a look at those blue numbers. Look at the original rules that generate the sequence and see if you can figure out where the connection is between the blue numbers and something in the original sequence. All right, so hit pause, see if you can come up with that connection. Now, if this is what you came up with, then you found the connection. The number that multiplies the variable is the number we end up counting by. Okay, and that should make sense if you think all the way back to elementary school. What is multiplication? It's just repeated addition, right? I am repeating adding 7 in this sequence because 7 times 1, and 7 times 2, and then 7 times 3 is what I'm doing. I'm repeating subtracting by 3 in that sequence because I'm doing negative 3 times 1 and then negative 3 times 2 and so on. Okay? So the number that multiplies the variable ends up being the number we count by. And what is this other number? What is this? Okay, you would have to look a little bit more closely to figure out, but what this number is, I will call the 0th term. Okay, the 0th term. And what do I mean by that? This is our first term, second term, third term, and so on. The 0th term would be the term that comes before my first term. So if I was to go backwards one more space, I would be going up 3. 240 minus 3 is 237. If I was to go backwards one space, I'd be going down 2. 11 plus 2 is 13. If I was to go backwards one space, I'd be going down 7. Negative 12. Okay? Negative 12 plus 7 is negative 5. Okay, so there's a connection between both of the numbers in my relation rule and the place I start and what I count by in my sequence. We're going to take all that information, put it together, and what I want you to be able to do is start with a sequence, write the rule, and then use the rule to find something that's far, far into the future of the sequence. Okay, so yes, you could find a pattern, continue the pattern until we get out to the 50th term. But if I can come up with a direct formula, I'll be able to jump immediately to the 50th term. So this is the process, the steps that I would have to do. First, what am I counting by? I'm counting by 4s. Okay, counting by 4s. That tells me that the beginnings of my rule are going to be q of x. All right, I'm pulling q from here, equals positive 4 times x. Remember, the thing that we count by is the thing that multiplies the variable. So that'll be the start of my rule, and then to finish out my rule, I'm going to say what term would have come before the first term. What is the 0th term? So I'm going to have to go backwards 4 from here, and I will have 119. All right, so that will finish my rule, plus 119. 4x plus 119 will generate that sequence. If I'm not sure, I can try a couple numbers. 4 times 1 plus 119. 4 times 2 plus 119. 4 times 3 plus 119. Make sure that they are actually giving me the terms in my sequence, 123, 127, 131. Okay, so this is my sequence rule. Then knowing that, I can say what is q of 50? Q of 50 gives me 4 times 50 plus 119, which will be 200, 319. All right, jump immediately to the answer without having to count all the steps in between. All right, so again, looking at another example. (18, 16, 14, 12, 10, and so on. My formula, m of x equals something times x plus or minus something. All right, my first something is going to be, what do we count by? And my second something is going to be, what's my 0th term? Okay, so what are we counting by? We're counting by 2's, but we're counting down by 2. All right, down by 2. So negative 2x plus, which term should come before 18? 20. 20, 18, 16, 14. So negative 2x plus 20 is my pattern rule. Then I could use it to find the 25th term. Negative 2 times 25 is negative 50, plus 20 is negative 30. All right, when the 25th term in the sequence will be negative 30. Look at another one. Count times variable plus zeroth term. All right, z of x equals. What are we counting by? If you're not sure, grab a calculator. Remember, I can subtract two terms. 46 minus 27 is 19. Just double check that that also works at the other end. 103 minus 84. Yep, we're counting by 19s here. So, plus 19 each time. That means my rule is 19x plus, what number is 19 before 27? 8. 19x plus 8. That's my rule. What's the 235th term? 19 times 235 plus 8. Use a calculator for that. 235 times 19 plus 8. 400 or 4,473. Okay, nice and simple. That's it for direct formulas. One of the most useful skills in Algebra 1, Lesson 26, is something that you want to learn. If there's ever a pattern, whether it comes in a table or in a sequence or even on a graph, you should be able to write an equation to match the pattern. All right, you've already seen a lot of constructed responses where there's some sort of pattern and they want you to write an equation for it. This is one way to do it. The two things that matter are, what am I counting by? Where am I starting? What's my 0th term? All right, so hit pause, try these three, see if you can do them. Then you'll unpause and check against what I've got. That's how it's done, and then I could find any term in the entire sequence. If I wanted to find a 200th term, just put 200 in for x. If I wanted to find a 5,000th term, put 5,000 in for x. Okay. If I want to double check that my rule is correct, I just use the beginnings. 9 times 1 is 9, minus 7 is 2. Cool, works with that. 9 times 2 is 18, minus 7 is 11. Cool. 9 times 3 is 27, minus 7 is 20. All right. So, another topic that you can easily check, are you correct, before turning in paperwork? And you should be good with it then.